Okay, imagine this for a second. You need to send a perfect, uncompressed 4K video signal from a laptop to a projector.
Sounds simple enough.
But the projector is a literal football field away.
Oh, well, that's an absolute nightmare for a digital signal.
Right.
I mean, if you're using a standard copper HDMI cable, the kind everyone has at home, that signal is dead before it even hits the 10-yard line. Physics just, gets in the way.
Exactly. But today, we're looking at the piece of gear that claims it can solve that exact problem. We're doing a deep dive into the product page for the Kramer CLS AOCH 6098.
That's a catchy name.
I know, right? But just look at this price tag. This single cable lists for $470.
Whoa.
Even on sale, it's $376.
That is a steep ask. You can buy a pretty decent TV for that.
So that's our mission today. Why would anyone pay nearly $400 for one HDMI cable? Is this just marketing fluff, or is there some serious engineering going on here?
It is definitely not fluff. To get the price, you have to look right at that acronym in the name, AOCH.
AOCH.
It stands for Active Optical Cable Hybrid.
Okay, let's unpack that. I get optical, we're talking fiber optics, but why hybrid?
This is the really clever part. See, pure fiber optic cables are amazing for speed, but they can't carry electricity.
Oh, okay.
So Kramer combined them. Inside this very thin cable, you've got 4 fiber strands doing all the heavy lifting for the video data.
And the copper wires are for what then?
They handle the handshake between your devices. Things like EDID, which tells the laptop what the screen resolution is, or CEC, so your remote can control everything.
Got it.
And the copper carries the 5 volts of power needed to run the cable itself.
Wait. The cable needs power.
It does. See, this isn't just a passive wire. The HDMI connectors on the ends are actually active transceivers.
So they're like little converters.
Exactly. They take the electrical signal from your source, convert it into pulses of light, shoot it down those fiber strands at 18 gigabits per second, and then convert it back to electricity on the other end.
So the connector head is basically a tiny computer.
Precisely. And because it's using light for the video, there is literally 0 signal loss. You can run this thing up to 100 meters, and the image at the end is mathematically identical to the source.
The specs here mention it supports 4K, 60 Hz, 4.4.4. Now, I get 4K resolution, but what's that 4.4.4 part about?
That's chroma subsampling, basically color detail.
Okay.
A lot of streaming services, they compress the color information to save bandwidth. It can make things look a little washed out if you look really closely. 4.4.4 means it's uncompressed. Cinema-grade color.
So you're getting the raw, full bandwidth picture.
The whole thing.
All right, so the tech is a beast. But why does the physical design matter so much here? I mean, for me, a cable just gets plugged in behind a TV.
Well, think about where these are actually used. They're being pulled through walls, ceilings, tight conduits in huge conference centers or theaters.
And those standard HDMI heads are huge. They always get snagged.
It is the absolute bane of every installer's existence. So Kramer solved this with a really smart design. The HDMI ends are removable.
Oh, that's clever.
You slide them off, and underneath is this tiny, streamlined micro HDMI connector. They even give you a little pull-through capsule to protect it.
So you snake the skinny version through the wall and just snap the full-sized head back on when you're done.
Precisely. And because it's fiber, not a thick bundle of copper, the whole cable is incredibly thin, only 3.4 millimeters. It has a bending radius of just 6 millimeters.
Wow.
You can route this around corners where a normal copper cable would just kink and break.
That really does sound like an installer's dream. Now, I did see another detail on the spec sheet. Low smoke and halogen free. That sounds pretty intense.
It's a major safety requirement. If you're running this in what they call critical infrastructure, a hospital, a university, a crowded public space, you have to think about fire codes.
And standard PVC cables are bad in a fire.
They release toxic black smoke when they burn. This material is designed to be much safer in an emergency. It really shows this is professional-grade gear.
It also has to be super reliable, I imagine.
Which is why the fiber is so key. You're often running these video cables right next to high-voltage power lines or Wi-Fi routers. Copper acts like an antenna that just picks up all that noise.
And that's what causes flickering or signal dropouts.
Exactly. But fiber is basically glass. It's completely immune to all that electrical interference.
So what does this all mean? We started out looking at a nearly $400 accessory.
But it seems like we ended up analyzing a piece of active hardware. It's not just a cable, it's a bridge. It takes a signal that was never meant to go more than, say, 15 feet and pushes it 100 yards without losing a single pixel.
So the next time you're sitting in a huge lecture hall or a theater and the presentation on screen looks absolutely flawless.
Just remember, there's probably a very expensive, highly engineered hybrid cable like this hiding in the walls, making it all happen.
It really does blur the line, doesn't it? We think of cables as just passive pipes for data.
But if the cable is actively converting electricity to light, managing encryption, handling its own power,
It makes you wonder, at what point does the cable stop being an accessory and just become another computer in the signal chain?